Hello, math students. Welcome back to Module 11, Geometry. This is Lesson 16, and it is called Changing Scales. Our goal for today we will learn how to determine the scale factor from one drawing to another. The question that I want you to think about in this lesson is, can you use a ratio to determine the scale factor? So we're going to talk about some things to remember. Just as we were learning in our lesson yesterday, we learned that the scale factor tells what kind of scale drawing is being produced. Scale factors are determined by dividing one corresponding length by the other corresponding length. In the formula, quantity equals percent of whole. The percent is the scale factor. The whole is the length of the original, and the quantity is the length of the scale drawing. If the lengths of the sides are not provided, but two scale factors are provided, then you use the same relationship, but use the scale factors as the whole and the quantity instead of the given measurements, and then you can determine what the scale factor would be. So some quick things to remember. In yesterday's lesson, we learned that when you have an original drawing, you learned that it will always represent 100% because it's the original or the whole. Then we also learned that if you have a percent that is less than 100%, then you know that it is a reduction. And if you have a percent that is greater than 100, then you know it's an enlargement. So you need to remember those little bits of information when you're working on this. The other thing that we need to also be mindful of or remember is what corresponding means. Corresponding means that you are representing the same side of whatever the shape is. So we would have to say that if we had a drawing that looked like this, where we have one house, okay, that looks like that, and then we have another house that looks like that, and I tell you that this is a certain length, this length of the roof corresponds with this length of the roof. So you have to use the same piece of the drawing to correspond with so that you can compare the same piece of the roof. And that's why it's talking about that scale factors are determined by dividing one corresponding length by the other corresponding length. So you have to use the same piece of information on both drawings in order to figure out what the scale factor would be. All right, so now let's take a look at this problem down here and we'll try one. It says, try it. Compute the scale factor as a percent. So it's telling you already that you have to figure out what the percent difference in size these two drawings would be. So we see right here that this is a drawing of one pocket, and we see this right here is the drawing of another pocket. Okay, and so what it says is, we have the whole is the length of the original and the quantity is the length of the scale drawing. So you have to decide which one is the original and which one is the scale drawing. And you can do it either way, and it should come out both directions. Now, you will get a different answer depending on which one you choose, but we'll talk about that in just a minute. So for the first one to try, I would like to say that the little pocket is going to be the original. So if we say that the little pocket is the original, then we know the corresponding length that they're wanting us to use is this length right here because it happens to be this side length and this side length is labeled. So if we're saying that pocket number 1 is the original, so go back up here, it says the whole is the length of the original. So remember, we have the formula that we spent a lot of time on. Quantity equals percent of whole. Okay, so it says that the whole is the length of the original, so we have 1.60 times a percent, right, equals the quantity, and the quantity is the length of the scale drawing, and the quantity is 3.36. So now all you have to do is remember the rules of solving this, and if you wanted to, you could use a BU chart to help you organize your thoughts. So if we have a BU chart, then we know the variable was P. What are we doing to P? We're multiplying by 1.6. So to undo that, you're going to divide by 1.6, and you should be left with P. Okay? So we need to do divide by 1.6 on this side, and divide by 1.6 on this side, and then that will give us the P. Remember, we have to make sure that we pay attention to turning it into a percent. So this problem right here says 3 36/100 divided by 1 60/100, which if we multiply this by 100, we would get 160, right? And if we multiply this by 100, we get 336. And now we can divide these two amounts. And I'm going to say that I know that 16 times 2 is 32, so 160 times 2 is 320. And then we're going to subtract, and we get 16. Then if we put a decimal point in and bring down a 0, 160 goes into 160 one time. And now we have to turn that into a percent, okay? So turning that into a percent, remember if you have any decimal, so we have 2.1, we have to multiply it by 100. And when we do that, we see that this percent or scale factor for this pocket is 210%. So on this one, we're going to say the scale drawing equals 210% of the original. So we can say that 3 36/100 is 210% of or times 1 60/100 inch. So that's kind of cool. Does it make sense if you're saying this is the whole is small, and the scale drawing is way bigger? Does it follow the rule? Well, yes it does, because an enlargement means that it has to be greater than 100%. Is this greater than 100%? The answer is correct. So the scale factor from going from 1 to 2 is 210%. Now, let's go the other way. We're going to say this time that this is the whole. All right, so we can write a percent times 3.36 is equal to 1.60. Okay, so set up the equation, do a build and undo chart. Your variable is p. It says you're multiplying by 3 36/100. So to undo that, we have to divide by 3 36/100, and that will leave us with p. So we're going to divide this side by 3 36/100. What you do to one side, you have to do to the other. And so now we have 1 60/100 divided by 3 36/100. If we multiply both of them by 100, we get 336 goes into 160. And automatically, my brain says, okay, I can't, so I'm going to add a decimal. And now my brain is saying, okay, yes, you can. So now I just have to figure out how many times 336 goes into 1,600. And I'm going to try 5. So over here, I'm going to show my work of trying by 5. So that's 30. Then that's 15, 16, 17, 18. And then we have 5 times 3 is 15, plus 1 is 16. And we notice that's too big. So now let's try 4 and see what happens. So that's 24, 12, 13, 14. 12 plus 1 is 13. So we know that it goes in there so far 4, right? So that gives me 1, 3, 4, 4. And then this will be a 5. This will be a 9. This will be a 10. 10 minus 4 is 6. 9 minus 4 is 5. 5 minus 3 is 2. So now I have to bring down another 0. And we know times 5 equals 16. So let's try 8 and see what comes up with 8. So that's 48, 24, 25, 26, 27, 28, 24, 25, 26. So a little bit too big. So now let's try 7. See what happens there. 7 times 3 is 21, 22, 23, 24, 25, 21, 22, 23. So that one will work. So now we know that it goes in 7 times. 23, 52. Do some subtraction. That becomes 5. That's an 8, 0, 2. And then bring down another 0. So we know that 7 is too big. We know that 5 may be too small, so let's try 6. What we get, 36, 18, 19, 20, 21, 18, 19, 20, And that one is going to work. Now, my question for you is, do we have to go on forever? Because it's looking like this may go for a while. And hopefully you all can see that the answer to that question is no, because right now, if we take this amount right here and we multiply it by 100, we know that this number times 100 is going to be something of 47.6, and my next number, just looking at it, is that if we multiply 336 times 2, that's 12, 6, 7, that's 6. That's already too big, so you know this one's going to be a 1. So it is safe to say that the scale drawing equals 47.6% times the original. So we're saying that this is your original. When you multiply it by 47.6%, you get this size right here. Okay? So that's kind of interesting, and it does work, because if this is the original, this is the size, and in order to make it smaller, your percent has to be less than 100. Is 47 6/10% less than 100%? And the answer is yes. Okay? Boys and girls, does everybody understand what we just did? All right? Do not let the decimals freak you out. Do not let the long division freak you out. And then ultimately, the last step that you have to always remember to do is take your answer that you receive, depending on what it is, and don't forget that you have to multiply it by 100 to turn it into a percent. Okay? So it's kind of fun, you know, just trying to figure out what you're doing. So going back to our goal today we will learn how to determine the scale factor from one drawing to another drawing, which is what we just did. And then the question that we asked was, can you use a ratio to determine the scale factor? And the answer to that question is absolutely, because if you remember, finding a ratio, you just take one value and divide it by the other. So in this case, we would take 1 60/100 and divide it by 3 36/100, which is what we did right here. If you do it the other way, you're taking 3 36/100 and you're dividing it by 1 60/100, which is what we did right here. So as you can see, turning it into a ratio is absolutely the correct way to find the scale factor of the problem. Okay? All right, kiddos, that's all I have for you today. Talk to you soon. Bye.